Our next rule of exponents comes, we know that if we multiply x cubed times x to the fifth, that since those bases are the same, we're going to add the exponents together and get x to the eighth. But what if I want to take x to the third and raise it to the fifth power? We know that taking something to the fifth power means we're going to multiply it times itself 5 times. So 1, 2, 3, 4, 5. And then we know our addition rule from the right over there that says if I add 3 and 3 and 3 and 3 and 3, I'm going to get 15 total x's times themselves. Notice that what we did to the 3 and the 5 there is find the product. 3 times 5 is 15. Anytime we have a power and we want to raise it to the power, that's when we get to multiply the exponents together. So if we have x squared to the fourth, that's a 4. 2 times 4 is 8, x to the 8th power. If we have x cubed and we want to take that to the negative 2 power, we get x to the negative 6, which is 1 over x to the positive 6. If we have x to the negative 4 times x to the negative 5, negative 4 times negative 5 is positive 20, x to the 20th power. Now, there's something I left out of the last video, so I'm going to sneak it in here. I realized it after I published it. So we're gonna go back to this thought here for a moment. Okay. Let's say we have a fraction. Well, let's not do that. Let's say we have a fraction and the negative exponent is already on the bottom. Okay, we know x to the negative 6 means 1 divided by x to the positive 6. Okay, but let's say our negative exponent's already on the bottom. Okay. What's going to happen there is we're still going to need to rewrite it. We still want to make that exponent a positive number, but we're going to pop it up to the top now to make it positive. Okay, if we have 1 over a to the negative n, that becomes plain old a to the positive n. So maybe I have x to the negative 2 over y to the negative 5. Since the negative 2 on the x is on the top currently, that drops the x to the bottom and makes the 2 positive. It also takes the negative 5 on the y from the bottom, it brings the y up to the top and makes the 5 positive. When you're dealing with negative exponents, please be careful to only move the term with the negative exponent. Meaning if I have 5x to the negative 4 power, we understand that this number 4, this negative 4 here, is only the exponent on the x. It's only hooked onto the x and not the 5. If we needed it hooked onto the 5 as well, what would we have to put there? Hopefully you're all saying or thinking parentheses. Okay, so since there's no parentheses, that negative 4 is only hooked onto the x, which means the 5 stays on top and only the x to the 4th goes to the bottom. Okay, extending on this idea here, our product rule, okay, which is different. That is a lie. Look at what I did. That's not x to the 20th. I hope you were all yelling at me at home. What should that be there? If I add negative 4 plus negative 5, I get negative 9. Okay, this is an addition rule, just like this one was up at the top. Okay, negative 9 means 1 over x to the 9th power. Okay, good grief, I got my eyes crossed this morning. Okay. if you ever, this is a good public service announcement right here, if you ever find a mistake in one of my videos, which is going to happen from time to time, as I've just proven right here, please, please, please send me an email about it and tell me what you found and what you think it should say. And I'll go back in and I will post a correction so that I don't screw up the entire class and make you believe things that aren't true. All right, so again, extending on the product rule, which is what this video was meant to be about when we started. Okay, we said if we have x to the 7th to the 3rd, then a power to a power means we multiply those exponents together and get 21. What if I have x squared y cubed, and I want to raise that to the 4th power? Okay, I'm going to write one more out using the long method, but the parentheses here indicate that 4. I'm raising everything inside to the 4th. So the x squared y cubed 4 times. Okay. We start counting up the x's, and we have 8 of them, and we start counting up the y's, and we have 3, 6, 9, 12 of them. If I have a product raised to a power, notice that what happened there is that both pieces of the product got raised to that power. It means I took power to a power and I multiplied to get 8. I took this power to the power and I multiplied to get 12. The rule is the same if we have a fraction. A quotient to a power means hook the power to the top, hook the power to the bottom. That says B. So if I have 3x to the 4th, y to the negative 5th, and I want to square that, that 2 is hooked onto all of the pieces. Okay, and don't forget to hook it onto any of the numerical values out there as well. 4 times 2 is 8. Negative 5 times 2 is negative 10. My cleanup step for my final answer, I'm going to rewrite 3 squared and call it 9. X to the 8th, positive exponent stays right where it is. Y to the negative 10, I'm going to drop that down to the bottom. Okay. This is what that's going to look like. Alright, I'm going to make a separate video that just has lots of extra examples in it, but I think we've hit every rule but one, so let me sneak that one more in here. Okay. In order for all of our rules that we've been working with, for them to all be true and hold true for all of the situations, okay, what that means is if I have something raised to the 0 power, the 0 power is equal to 1. Any number raised to the 0 power, I say any number but 0, but nobody in your algebra classes will ever ask you what 0 to the 0 is. We don't worry about that right now. Okay, but any non-zero number raised to the 0 power is equal to 1. So negative 12 to the 0 power is equal to 1. 0.5678 to the 0 power is equal to 1. Okay, 3 to the 0 power is equal to 1. Where you have to be careful is if someone does this to you. Negative 4 to the 0 power written that way is not equal to 1. What's it equal to? Negative 1. Okay, this goes back to the very first days of class when we were reviewing things, and it goes to the example that I just pointed out on the other page. I can go back to it maybe in a minute. Okay, the 0 is only hooked on to whatever's directly below it, which in this case is the 4. If I needed the negative to be hooked onto the 0 as well, then I have to put parentheses around it, like we did here with the 12. Okay, so in the yellow box here, that's equal to positive 1. And then the negative sign out in front gets to tag along for the ride. We have to pay attention to detail in math class. In any problem, even short problems like negative 4 to the 0 power versus negative 12 in parentheses raised to the 0 power. Okay, so please be sure you get a hold of me if you're unclear about the difference. Okay, and look for the video that has more examples in it.